Cameron. So thank you, everybody, for attending virtually in person. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 people in person. I do not know how many people are online. I can only see 8. Is there how many? What do you got in the chat group there? 8. 8. All right, so we have quorum, 17. In-person outnumbers online. Oh, well, we're not counting Cameron. There's equal numbers. So tonight, Cameron, can you describe what you're going to be talking about?
Yeah, sure. So this evening, we are going to talk about how to learn some basic functional programming concepts by rebuilding our version of LINQ. And we're actually going to do that by refactoring some maybe not so great code.
Excellent. So my name is Scott Locke. I am the CEO, co-founder of Inferno Red. We are sponsoring the amazing pizza in the room that the virtual attendees will have to just dream about. If you too can buy it yourself, if you just order Papa John's. Make sure to get the cookie. Tastes like pizza, but it looks like a cookie. And Lee Richardson and Labrina, and I don't Loving. Sorry, Labrina.
Sorry.
Labrina Loving are your hosts. I am the former host who still seems to be doing the introduction. So that's what we got. And Van is here. Say hi, Van.
Hi, everybody.
All right. I just want to get that on the record and record it for everybody else. So with that, Cameron, take us away.
All right, so I'm going to do the stereotypical thing. I'm going to share my screen here. Hopefully everything works. All right, and if everything is working correctly, you should see a very stereotypical PowerPoint presentation. Either thumbs up in the chat, anything verbal, that would be great. Sweet. All right, we're cooking. So good evening, everyone. Welcome to Level Up on Functional Programming by Rebuilding LINQ. Before we get too deep into everything, I'm going to help us out a little bit here. So everything we're going to talk about tonight, slide deck, blog post, code sources, everything is already live. If you go to blog.softwarementor.com/presentations or scan that QR code, if you trust me, you will get everything you need. However, you will not get the awesome narration for the presentation. So I'd recommend still sticking around with me for a little bit here. So we're just going to go ahead and get into it. What exactly are we going to get into this evening? So first and foremost, I want to level set a little bit about what exactly is LINQ and some of the cool things you can do with it that may not be abundantly obvious. We're also then going to take a look at about what are the 3 things that actually make LINQ work, right? And as we talk about those 3 things, we'll kind of talk about how C#, the language, had to introduce these concepts in order for them to do LINQ. Without any one of these 3, it falls apart. And then once we've set the stage, we're actually going to refactor some not so great code, like I mentioned before, to our own versions of LINQ. So instead of calling it select, where, and aggregate, we're going to call it map, filter, reduce. And as we look at those new functions we're going to refactor to, we'll talk about some of the interesting properties that those functions have that maybe you may not always think about when you're using LINQ. Depending on time, we may look at some code a little bit more hands-on. Not sure yet. We'll kind of play it by ear a little bit. Do me a favor, if you've got questions in the room, feel free to kind of shout those out. Just remind me that, just, hey, Cameron, I got a question, right? That's okay. If you're in the chat, right, if you're online, leave a question in the chat. I'll be quiet at certain points, and Lee or Scott or Labrina, I'll ask one of you to kind of help me moderate the chat during the presentation. Otherwise, we'll get into it. So what exactly is LINQ? Well, let's say we've got some C# code, right? So we've got some class called delivery team, and it's got some properties, right? Nothing too terribly interesting here. It's got a name of a team, the person who's leading the team, and the number of people on that team. So we've got some canned data here. So we've got a team called alpha team. We've got back to the code, got skill overflow exception, and we've got getting things done. And you as a developer may be looking at this and you get tasked to write some code to solve the following problem, which in this case is, hey, we've got some delivery teams. We need to figure out which of these teams have more than 7 members on them. And maybe you're trying to figure out how many teams are maybe too big, might need to be broken up a little bit, maybe violate the 2 pizza rule, so on and so forth. So if you're not familiar with LINQ, maybe the approach you would take would look something like this, right? Where you've got a list and you're going through a for each loop. Now, this is all well and good, but does anyone want to take a guess about the code that's actually important, the actual business rules? And I'll give you a hint, there's only 2 pieces of all this code that's actually important.
The if statement.
Yeah, exactly, Lee. Like I believe that was Lee that said, yeah, it's pretty much the if statement. So really, you've got the if statement of, hey, is the member count greater than 7? And then you need to know that you're trying to grab the team name. But otherwise, that's about it. So when I look at code like this, why is it that I've got a lot of boilerplate that's kind of hiding my intent, right? I have to parse through the for each loop. I got to parse through the if statement. And this is pretty simple, right? For those you've worked in kind of larger code bases, it's usually not a simple if statement, right? It's usually multiple if statements or compounded if statements, right? Or it's more nested. It's never this simple. But in the cases that it is, why do we have all this boilerplate? Well, when I look at LINQ, well, this is what we would have written. We would have said teams.where member counts greater than 7. And then for the selection, we've been grabbing the name. What I like about this approach is that those business rules, that context we were just talking about, they're front and center. There's no real parsing I have to do here. As long as I understand what the where operator does and the select operator does, it kind of has to work this way. So it's kind of cool, right? And when we take a look at the docs for LINQ, what we have here is that it's a set of operations that work on data that's independent of the source. And not only is it independent of the source where the data came from, it's also type safe, which means that you can catch stuff via the compiler way before you actually have to try to run the code. Now, how many of y'all have ever done inline SQL and then had to fire that across the wire to a database? Right? How many of y'all have actually ever written the SQL correctly on the first try? How many times have you maybe misspelt select or where or accidentally added a wrong syntax somewhere and you didn't realize it until you actually try to run the query? Right? LINQ's kind of cool in that it tries to catch a lot of that stuff at compile time, so you don't even have to run it. And the cool thing I also enjoy about it is that it's independent of the source. So Lee and I were kind of talking about this earlier this evening. It can work on objects, whether that comes from a database, could come from a file, doesn't actually matter. It all still works. And to me, that's fascinating, right? Because I don't know about you, but it's pretty hard to design software in such a transparent way that you don't have to have like a file adapter and then a database adapter. It's kind of cool it works this way. And we're going to look at tonight on how that actually works. Combining more into LINQ, right? This is why I find it important, helps us cut down on the verbosity of the code. But how does it work? Well, there's 3 concepts that we're going to go a little bit deeper into to make sure that we're clear. First, we need to understand what the func type is. What exactly does it do? What's some cool stuff about it? It still surprises me that generics weren't in the first version of C# because they're so ubiquitous today. But we got to understand how exactly generics work and how to use them appropriately and when it makes sense to refactor to generics. Last but not least, extension methods. And to me, this is kind of the hat trick, right? Extension methods is what allows you to get away with the whole data independent of its source. So we're going to look at each of these 3 things a little bit deeper now. So I'm going to pause here to see if there's any questions so far. Wonderful. Not hearing anyone shouting at me saying that I've misspelt something. Doing great. We'll keep things rolling. So let's talk about functions, right? And funcs in particular. So they were introduced back in C# 3.0, so I think that puts us somewhere around 2008, 2010, around that time frame. And funcs are interesting because it's a data type, right? But it returns a value when you invoke it. And that's kind of a unique concept. There's not too many things in the C# language that work this way because methods come to mind, but methods aren't a type per se. And so when you invoke a func, it gives you back a value, and it requires 0 or more parameters or inputs to make that work. So let's take a look a little bit at type signatures. So we have a func of ints, and the way to read this is that this is a function that takes in 0 inputs, but it's going to give you back an integer. And so an example implementation may look like the following, where we have get number. It takes in that open close parenthesis. It's going to return you back the number 2 every time. Right? Let's take a look at a little bit more complicated of a func though. This signature func int comma string tells us that, hey, if you give us an integer, we're going to return you back a string, right? And so an example implementation is maybe we write our own toString function that's really just going to call toString method off the integer. It's not maybe an interesting one, but it works, right? And we can keep exaggerating and complicating the signature as much as we can. Your fun fact of the evening about funcs is that I believe you can specify up to 10 generic type parameters here. So you can make them very complicated, but if you're thinking of doing it that, please don't, right? Think kindly of your other engineers. But in this case, we have, getting us back on track a little bit, we have a func int comma string, and what this says is if you give us a number and a string, we're going to return you back a new string. And so in this case, here's some C# code that allows you to repeat a string, right? So if you gave me the number 4 and the word hello, it's going to give you 4 hellos concatenated together, right? The contents of these functions isn't important. The importance is understanding type signatures, right? Like when we say func int, what does that mean? And for those of you who've actually used funcs before, or used LINQ before, you've actually used funcs. In fact, you've already seen them tonight in this code, because that where statement, the whole member count greater than 7, that's a func. It was a function that says, hey, given a delivery team, I'm going to give you back a Boolean. That whole select thing that we did, yeah, it's a function too under the hood. It's a function that says, hey, given a delivery team, I'm going to give you back a string. It's pretty handy. But you know what? Funcs are kind of interesting too, because they also can shadow other methods. Let me show you. Let's say that we had this code and we wanted to extract this out to its own thing. Maybe we want to give it a name. Well, we can do that. We can create a func, but we can just literally lift and shift those functions to their own variable definitions, call it more than 7 and get name, and then drop those back into the where and select clause. This will work. This will compile. No harm, no foul. And in fact, this is a great approach if your func is a little bit more complicated, right? Maybe it's not just a simple one-liner. Maybe you want to give it a more descriptive name. But we can actually go a little bit further. We can also extract those funcs into actual private methods. So in this case, we have, does team have more than 7 members? That works. And that's because the C# compiler is able to infer like, hey, this method, I can actually make that a func for you. And so the compiler is doing a little bit of magic to make that conversion happen for us, but this will totally work. It will compile, no harm, no foul. And as you can imagine, if you can get to methods, you can then move these methods to their own classes, instantiate them, all that fun stuff is going to work here. Pretty cool. So what are some cool reasons to use some funcs? So from my perspective, funcs are great if you have some logic that you want to put a name to, right? It's kind of like that more than 7 instead of just reading just raw code there. I get this question a lot. Hey, if you're using C#9 or later, you can actually use local functions. They'll work to the same effect. The key thing to remember here, though, is another use case for funcs is that it allows you to parameterize behavior without having to create a whole object and a whole class that you need to inject, right? Instead of doing up classes and passing them around, you could actually just pass around funcs. And you saw that a little bit with the more than 7 and select team name. You'll see that a lot more when we refactor some interesting code this evening. Otherwise, that's all we need to really cover about funcs. So let's take a look at the next thing. Let's talk about generics, right? I joked earlier I had a cup of tea. Well, I literally do in this case. It works out. So generics got introduced in C#2, which I believe is like around that 07, 08 timeframe. And these are type parameters. So this allows you to parameterize on a type. And this is cool when you can write code where the implementation actually doesn't change a ton. You just the types could be different. Let's look a little bit closer. So on this screen, you're seeing some definitions for lists and then the func we used before. When working in C# code, you know you're actually working with generics because you're seeing these angle brackets. Anytime you see an angle bracket, hey man, we're working with something generic here. It's pretty cool. So let's go into some somewhat realistic code. Let's say that you are writing a code assignment, whatever, and you need to implement a queue. Right, so we've got a number queue, right? It's going to match over a list under the hood. It's got an operator to add something to the queue, and it's got a way to pop it. That's pretty cool. And you get the number queue out there, and all your engineers and your product owner are super excited. And then, of course, the business comes to you and says, hey, wait, it's cool that you got this, but we work with strings. We work with strings a lot. Can you make this work for strings? And you go, yeah, we can totally do that. So you write the version for strings. And you're an engineer, you're probably good with patterns, and you go, huh, interesting. These two files look very similar to one another. In fact, they look so similar that really the only difference is that the type here is different. This is a very strong clue that, yeah, we should probably use some generics here. So let's take a look at what that refactor could look like. So what we do is we create a new class called Q, and we're going to mark that's generic. How do we mark that's generic? Because as part of the class definition, we put that bracket T. And the minute we do that, everywhere in this class definition that you see a T, it's the same one at the class level. Has to be, because they're following that same type parameter. And then once we've done that, we can just keep substituting T's out as so, and this works. So now instead of having both a string queue and a number queue, we can just say queue of string, queue of int, and work with those as normal, and everything else works correctly. Once again, I mentioned this earlier in the presentation, but it still fascinates me that people were having to kind of hand roll their own generic collections for a while. Still astounding it wasn't in the first version. So that's kind of it. Generics aren't too terribly hard of a concept, but like, at least from a syntax. But the clue there is when to use them. And really, it's when you're writing that third thing, that third data structure, that third function, that third method, right? Where you're like, this looks really similar. Maybe we should go ahead and put in that refactor, right? So I'm going to take a pause here to see if there's any questions so far about what we've talked about. No? Okay. Hey, if this is all making great sense, that's awesome. That tells me I need to either go faster or more complicated. We'll see which one I choose. So last but not least, for like this third thing to kind of make the magic work, let's talk about extension methods. So they were introduced in C#3, so at the same time that funcs were, and you're starting to sense a trend there a little bit. And the cool thing about extension methods is that they allow you to give additional functionality to a type that you may not own, right? And it does in such a way that you don't have to recompile the original code base or anything like that. That's kind of neat. So it's kind of hard to see in the room in the chat, so feel free to come off mute, whatever. How many of you all are working with ASP.NET Core, like either Web API or MVC? Yeah, a couple of hands, right? How many of y'all use like the standard controller routing for names, right? So if you have like the weather forecast controller, then it goes, you know, the API was wired up to all of that, right? So all of that configuration, right, it kind of happens in that startup file, right? Startup.cs for the most part, right? Yeah, kind of. Most of those things that tie onto the service builder or to the app are extension methods. Almost all of that is. Kind of cool, right? And and I mentioned the service registration a little bit. It's a pretty common pattern to put all of that behind an extension method anyway. So if you're working with ASP.NET Core, you're using extension methods all the time, whether you may have realized it or not. But let's take a look at some pretty interesting cases that you could use extension methods for. So when working with extensions, it's a naming convention to have it be name of class you're extending followed by extensions. So if you see string extensions, that means we're probably extending the string type. And then to make them extension methods, you have to have it as a static class. Otherwise, the compiler's not going to be very happy with you. It's going to bark at you. case, we're going to create an extension method that will capitalize the first letter of the string. We know it's an extension method because it's a public static method, and that parameter is a little bit interesting, right? It's got that this keyword. That's the magic. The minute you put the this keyword in front of the type like that, it's going to tell the compiler like, hey, I'm going to work on anything that's a string. And then at this point, we can write whatever our business rule logic is using kind of the S parameter. So I could have called string extensions anything. I could have called it super awesome magic, but the minute I try to do string dot capitalize, it'll bring it in. It will actually make this work. So here's one way I can do it with capitalize, and then we could write another extension method called crazy case, write whatever terrible code I just wrote here to let it alternate the casing of the word. But suffice to say that you can keep extending these things for as much as you need to. Right, not a big deal there. Right. And so I mentioned this a little bit earlier today, in the presentation, about tying into that whole service config. Yeah, all that stuff, most of these are extension methods, and I could have written my own. So in this code base, I wanted to tidy up all my dependencies. So I wrote an extension method that actually does the whole IOC wiring up. So that way my startup.cs file isn't, 10,000 miles, long. Here comes the fun part. If you understand extension methods, generics, and funcs, you could have invented LINQ. So much so, in fact, and extension methods are such a key part of LINQ that if you were to go to the Microsoft docs on extension methods, here's what you'll find. The most common extension methods are the LINQ standard query operators that add query functionality to the IEnumerable and IEnumerable of T types. Because that's the most well-known use case for these things. So let's get into coding, right? Let's start figuring out our way to write our own LINQ methods here and how we could kind of derived or found out our own. So there's a couple of guidelines I'm going to hold us to while we do this. So the first requirement is that we're going to write extension methods that are off the IEnumerable type. That's how we're going to do it. It's how LINQ kind of operates. It's kind of what the doc says. So that's what we're going to do. The next thing we're going to follow is we're going to keep the same signature. Now, to make sure we don't have like a namespace conflict, I am going to call the functions a little bit different. So instead of select, I'll call it map. But otherwise, it's going to have the exact same type signatures as the regular LINQ operators do. Last but not least, we're also going to talk about the properties. So we're going to keep the same ones. So with that being said, let's take a look into map. And this is a function that lets you change types. So select, for those of you who may not be aware, says that if you've got a collection of one type, you can change it to a collection of a different type by using some type of mapper function. Now, select has a really cool property to it. And that property is that it maintains the length of the collection. So if you give it a collection of 5 items and call map on it, you're going to get a collection of 5 items, not 4, not 6. That's kind of cool. It's kind of guaranteed to have that. So let's take a look on how we can write our own version. So here is our delivery team object from before, right? We've got, 3 properties of name, a team lead, and member count. And we've got this new requirement from the business saying, hey, we've got some delivery teams. We want to see all the names of the teams, right? We're creating some reports or whatever. So we go, all right, cool. I'm going to write this code. Remember, I don't have LINQ, so I can't use it here. So I go, yeah, I've got this list of team names. I'm going to iterate through the teams. I'm going to add the name to this list. That code works. We ship a feature. Yippee-ki-yay, hurrah. Things are good. But man, we keep finding out that we want to use this logic in quite a few places, right? Like it's not quite enough to be a class, but we don't want to copy paste this everywhere. So one thing we could do is we can go ahead and level this up to an extension method. Cool, not too bad. So we can create a static class called delivery team list extensions, give it that static method with this keyword and say, yep, we're going to extend off the list of delivery teams. Same code as before, right? This is pretty much a lift and shift. And hey, we've got it We've got our logic in one spot. We've not duplicated in 50 million places. If we need to change the logic on how we get team names, we do it in one spot. Great. Hurrah, we've cleaned up some code. Things are great. But man, business always wants to get more stuff. I always want more stuff. So now we've got this new requirement that says, hey, given this collection of delivery teams, we want to see all the team leads. We go, all right, we know the song and dance. So we do the team lead names. We'll just go ahead and add that to our extension file. So we add another extension method, and no harm, no foul, this will work. But we start thinking, this is what our extensions look like so far. Man, this code looks real similar to each other, right? Like some variable names are a little bit different. But if I ignored the variable names and the method name for a second, there's really only one difference between the two. Anybody want to take a guess what the difference is? It's what we're doing in the ad. Exactly. That's the only difference between these two methods. And so we start thinking, that's weird. I wonder if we could dry these up a little bit. So we learned that, hey, wait a minute, we totally can. So what we've done is we've created this new extension method called getStringValues that still extends off delivery teams, but now it's got this cool little func sitting over here, right? It's got this getter func that says, hey, given a delivery team, let's get a string off of it. And then once we have that, we can use that function over here. That'll totally work, no problem. But now how does this simplify things? Well, our get team names looks like this now. So the code that's commented out is what we had. But now we say, hey, yeah, teams, get me the string value where team of team.name. And then same thing for team lead names. So this will work, right? Other clients are still using get team names, get team lead names. We've not broken anything, but we've simplified our code base quite a bit, right? We've removed some code. It's not too bad. If we want to get more string values, we can. That's pretty easy. And so on and so forth. And we've got a problem. And the problem is that the business wants more stuff. So we've got this collection of delivery teams. Now people will know, like, all right, I need to know how many people are on each team. And you're like, oh, God bless, man. We get this figured out. So we write this code. So we get team count. We're using that list of delivery teams, integer, made an extension method, all that same such. And that's all well and good. But, we fast forward a little bit and we write this whole get int values implementation, right? So we're not duplicating that code again. But now we've got this get string values function and this get int values function, right? I got these two extension methods. These look kind of similar. What's the difference between these two now? It's the type. That's it. Ignore the variable names, but otherwise it's just the types. Well, we just talked about this, right? If you've got multiple things that have the same implementation, the only thing different is the types, we can probably genericize that. So let's do that. So what we've done is we've created a function called map now, and it's going to use a generic called tResult. Now it didn't have to be called tResult. I could have called it tcumquats. It doesn't matter. Naming convention, though, is that your generic should probably start with the T. Otherwise, other things will be a little bit unhappy about, but that's a naming convention, not a hard and fast rule. But now that I've got this tResult, right, and I've changed some variable names, but otherwise it's the exact same code that we've been writing. So now let's see what gets cleaned up. Well, when we go refactor this for get int values and get string values, they look exactly the same. So you can get rid of those because they're the exact same thing as the map call. So let's burn that code. Our get team names, get team lead names, and our get team count extension methods, they're all using map under the hood. So that's kind of cool, right? We're using this one map thing and it's working out pretty well. That's neat. But we can go a little bit further. Is there any particular reason why we need to stay on list of delivery teams. Is there any reason why we need to keep that constraint? No, and here's why. Let's say that we had a new data type. Maybe it's pizza deliveries, right? All of their map functions would look, hey, given a pizza delivery, here's the thing I want off of it, right? But you would write very similar code. So why constrain it this way? So we're going to update our map to not be an extension off of delivery team, but off another generic, and we're going to call that generic T source. So, right, so we literally took everywhere that had delivery team and just replaced it with T source. That's all we did. And once we've done that, this will all work. We can refactor. Can I let you on a little secret? That's actually pretty darn close to the real implementation of select that's in the .NET source code. And it has to be. Given the type signatures and the properties of select, there's only really one way you could have written it, and it has to follow this. Now, for those playing along at home, you may realize that I'm showing you code to a toList method, and that's because Microsoft has some performance things it does, whether you're calling toList or toArray or to whatever. But this works. And it's not too terribly different. It can't be. But remember, I said that we had to extend off IEnumerable, not lists, right? Lists lets you cheat. You could do things like size and length and some other stuff. So let's actually make this extend off IEnumerable. So once we do the IEnumerable thing, we literally, the code actually gets simpler. For those who've not dealt with IEnumerables before, the thing that we need to worry about here is when we do a for each, you just do the yield return. That's how you'll get an IEnumerable back out. But now you can work on anything, right? This will work on iQueryables. This will work on anything that implements the IEnumerable interface. You wrote your own custom tree structure. This will work on it. You wrote your own queue. This will work on it. You wrote your own whatever thing that you're dealing with. This will work on it. No problem. And this is pretty short code. It's not too much. So for those not used to working with map, you really use map to transform the collection from one type into another. And here's where I'm going to pause, because that was a whole lot of code to talk about in a short period of time. So is there any questions, anything we want to dig a little bit deeper into this refactor?
Does
No?
anyone have any question about yield? Because there's a bit of magic going on there that's kind of interesting. I mean, that's more than just returning an IEnumerable, right?
Yeah, so and Lee, it sounds like you're leading me into a direction that I may not be following, so that's okay. So the cool thing about yield is the minute you start doing this, all of a sudden your code's a little bit lazier, right? Up until this point, everything was immediate, like it had to happen in real time. But the minute you make it yield, you've got an IEnumerable. That means your code's lazy. That means it doesn't actually compute anything until you call certain methods like toList, toArray, the first or defaults, like that type of stuff. But this is actually kind of powerful because you can chain multiple selects and wheres and stuff together, and it won't actually execute until you need something. So you can actually pre-compute a lot in LINQ that way. So Lee, I have no clue if that's the direction you want me to take to, but that's one that came to mind.
Yeah, no, I mean, that's some of the magic for me. I love that.
Oh. All right. Well, let's talk about the next one. We're gonna go with keep. So in functional parlance, or if you're working in other languages, you'll either hear in LINQ it's called where. A lot of languages call it filter, and I actually hate the word filter. It's where I think Microsoft did a better job because it's hard to keep. It's hard to remember, is it filtering things out or filtering things in? So I prefer keep, so that's what we're going to call it. So what where and keep do is that it gives you back a subset of a collection based on some predicate, some rule. And this has a ton of properties that a lot of people don't think about. So the first thing you're guaranteed is that if you have some collection and you call keep on it, you're guaranteed to get back a collection that's somewhere between 0 and the original length. So if you call keep on a collection of 5 items, you're going to get somewhere between 0 to 5 items back. You're not going to get 6, not going to get 7. It didn't create anything out of thin air. In addition, it can't give you back items that weren't in the original list. So if I call keep on a list of numbers from 1 to 5, and let's say I'm wanting all the even ones, it can't give me 6. It can't give me 2, 4, 6 because 6 wasn't in the original list. That's kind of cool. It also maintains order, right? So if I call on the list of numbers from 1 to 5 and I want all the evens, it will give me 2 and 4, not 4 and 2. It can't do it that way. So that's kind of neat that there's a lot of properties in this really simple thing. So let's go write our own version of this. So here's back our delivery team, right? And you may recall our original problem if we have more than 17 members. So I'm going to short circuit some of the refactoring, and we're going to go straight to an extension method that says get too big of teams. And we've got iterable delivery teams. We've already got all that wired up. And we've got this logic, right? Some for each loop. And then if the member count's greater than 7, we're going to yield return team. All right, we're going to short circuit some of the refactoring, but we can derive this pretty easily. Okay. But now we get additional requirements, right? Hey, we want to make sure that Dana isn't leading too many teams. So let's go figure out which delivery teams have Dana as a team lead. Well, here's what this code looks like, right? We're going to go through each of the teams. If the lead is equal to Dana, return that team. Once again, we're pretty good at pattern recognition. So when we look at these two extension methods, we go, huh, this looks real similar to one another. So what's different?
If.
Yeah, the if checks. Checks are the only thing that's different. So what's a technique that we've seen tonight where we can parameterize that behavior? What could we extract it to? I'll give you a hint. It's either funcs, extension methods, or generics.
Pass func.
Yeah, we gotta get funky up in here, right? So we're going to do funcs. So yeah, and in fact, we actually know a specific type of func it has to be. It actually has to, since it's using an if check, we know it's returning a Boolean. So it's got to be some func of delivery team to Boolean. Now, for those of you who've been in .NET for a while, you may recollect there's an actual predicate data type. That's essentially just a wrapper around func of Boolean. But once we inject that predicate in here, here's what all that code turns into. And now we just have get teams by whatever predicate. Pretty neat. And in fact, yep, there we go. Cool. Sorry about the animations. And then when we go back to refactor our extension methods from before, here's what it looks like. Get too big of teams. Yeah, man. Here's get teams by the ones that are member counts greater than 7. Similar thing for get teams led by Dana. Very similar concept here. Right, not too bad. So here's our implementation. And I get to ask the fun question. Is there any reason why we have to be limited to this code working on delivery teams? Right, take a look inside the actual extension method. Is there anything that we're doing that's assuming that we're working on a delivery team? I don't see the delivery team type on the for each loop. I don't see it as part of the if statement. I don't, obviously not the predicate, and definitely not on the yield return. Since this function doesn't care if it's working on delivery team or not, that means we can make it generic. Right? So we take the top code and replace it with the bottom code. And you're like, huh, that is pretty darn similar. And in fact, right, because the only differences are the types like we talked about. So what's cool is if we take a look at this implementation compared to Microsoft's Where implementation, once again, looking at the to-list version, looks awfully similar. Right, creates a list, for each is through everything, and then if it's got and if the item matches the predicate, add it to the list, return list. I'll give you, how many ways could we have written this function though to fit the properties, right? Listing off iterable works on generics, maintains order, can't give you items that were on the original list. How many ways do you think we could have written such a function? I kind of alluded to it a little bit earlier. There's only 2 ways we could have written this, and that's depending on how we wanted to do the predicate. Right, if we negated it or not. Otherwise, there's no real other way you could have implemented it such that it follows the properties of where. No other ways we could have done it. So for those trying to keep track, right, we use where and keep to keep data that we want to keep from that regard. So I'm going to pause here and see if we have any questions so far about what we've talked about. Man, if I'm doing such a good job explaining this stuff, man, I might need to switch my day job. Maybe I go more coaching. Like, no, it's a lot of stuff to take in, but yeah, I want people to ask questions, right? That's what I'm here for. Okay. Well, let's talk about the last one then, reduce. So the best way to think about reduce is that you're going from a collection of many things to a single thing. So I'm glad you all had some pizza because I'm taking all these eggs and I'm making a delightful frittata on the right here. So this is probably one of the more complicated things in the LINQ family. So I'm going to have a couple examples. So what Aggregate does, and most other languages call this reduce, it says, hey, if you give me a collection and some initial value and what we call a combiner method, I'm going to give you back a single value. So this is really different because when we looked at map and keep, those said, hey, given a list, I'm going to give you back a list, right? Given a collection, I'm going to give you back a collection. Aggregate and reduce doesn't do that. It says, hey, given a collection, a starting value, and a way to combine the starting value and something out of that collection, I'm going to reduce it all down to a single value. So here is an example implementation. So we're wanting to sum the numbers up from 1 to 10. So we've got some initial value of 0. I've got my adding function, in this case, the reducer, that says given 2 integers, I return back an integer, just going to do add. And then to get a total, I create a list of numbers from 1 to 10. And then I'm going to aggregate on it, starting with that initial value and then calling the add function. So this one's a little bit trickier to see it, but man, once you understand this pattern, this shows up all the time. Let me show you. So we've talked earlier about how can we get the number of people on a delivery team. Sweet. Now we want to know how many team members do we have in total. So we'll write code that looks a lot like this, right? We start with a total of 0, iterating through teams, add the member count to total, return total. Right. This is pretty much just keeping track of a running total, nothing too terribly complex to write home about. And now we've got this other requirement like, hey, we want to know all the team names in the company. So we write code that looks a little like this, right? We're saying, hey, here's the teams in the company. And then for each team in the list of teams, we're going to take their name and append it as a line to the string builder and then return string builder. Okay. At first blush, these two methods look like they don't really have much in common, right? Because some of them are using string builder, some of them working with integers, some of them are adding strings, some of them are adding numbers. It's not quite the same. But the pattern's here, right? If I take a look at both these methods, they have a very similar formula. They both have some initial value. They both have some way to combine the initial value, total in one case, string builder in the other, and then they both return at the very end. So they can actually be refactored to use a very similar pattern. Let's take a look. Holy kryptonite, that's a bunch of generics. So let's break this thing down. So we talked about earlier that reduce returns back a single value, right? And we know it's different. In some cases, it's a number. Some cases, it's a string builder. That already tells us it's generic. So let's use that with T result. Now let's break down the rest of the signature. We're already extending on delivery teams, nothing uncommon. But now we need some initial value. So we have to pass it in now, T result. And now we have to have that combiner function, but we know what that signature is. It's something that says, hey, given the current value, or sorry, the running total, an element from the IEnumerables, in this case, delivery team, I'm going to give you back a new total. We call that function the reducer function. And then once we have that, we have our example implementation, which we set the initial value, we go through the teams, and then we return that result. Pretty cool. So what does this look like in refactoring? Well, our total number of employees look like the following, where we have initial value equals 0. That reducer function is really the add function that we looked at earlier. The only difference is instead of adding two numbers, we're adding a number to a delivery team, but the concept is still the same. And then we call reduce. This code type checks will totally work, no problem. Same thing for formatted team names, right? Initial value is going to be that string builder. Our reducer function says, hey, given a string builder and delivery team, what do I need to do? And then we're going to call the reduce. And all this will type check, it will work no problem. Pretty cool. So I get to ask my favorite question of the presentation so far. Is there any reason why this has to work on delivery team? Let's take a look at the function. Is there anything inside of the reduce function that specifically says delivery team? No, right? It's T results, reducer, and a var. All right, well, that means we can genericize that one more time, which we'll do here. We give it switch out delivery team for T source. Everything else actually just works, right? The code would compile, no problem. And so this is what our implementation is. Here's what Microsoft's implementation is. Now, they do better error handling. I'll give them that, right? They're actually making sure that you have a non-null source and a non-null func. Otherwise, that last 6 lines of code is exactly what we derived. Exactly the same. The only difference is they called their func func and we called ours reducer. Otherwise, it's the exact same logic, and it has to be. There's not really any other way you could have written this thing. How? Because of the properties of what reduce says it does. What I found is when we start thinking about LINQ and our code in flavors of properties, we can start really writing our code in a way that can only work that way. It can't work 40 different ways. It has to work the way it works because otherwise code wouldn't compile. So to kind of summarize on what reduce is, right? It allows you to transform a collection to a single value by first identifying the initial value, writing some combining logic, and that's it. But I've got one more trick up my sleeve, but before I go down that route, I'm going to pause yet again. What questions do we have so far? None. Once again, man, if y'all follow reduce, man, I've went way too slow in this presentation. I should have just went straight more complex stuff at the beginning. That's all right. Let's take the next one. What if I told you we're going to reduce the LINQ we've written to only use the reduce function that we just derived? What? No, can't do that. Seriously, we totally can. In fact, it actually won't be that bad of a refactor. So here's how we're going to refactor our already existing LINQ to only use reduce. Let me be the first one to say, please, please, please do not do this in real production code. Right? Think of your fellow engineer. This is completely a thought exercise to just demonstrate that reduce is all over the place, whether you realize it or not. So when we are refactoring things to reduce, there's two things we got to figure out. What's the initial value? So in our case, what happens if the list is empty, right? Because that's kind of what map and keep work with. And then we got to figure out how do we combine whatever the initial value is with the next element. If we can figure these two steps out, man, we're smooth sailing. So let's take a look. So here's what we had for map from earlier, right? We have an IEnumerable and source, got that selector. So we got two questions to ask, right? What's the initial value? Okay, the way to think about that generally is what do we do if the source is empty? So I'm going to ask you all, hey, when you work with select and you call select on an empty list, what do you get back? An empty list, right? Cool. That's our initial value. In this case, because we're working with enumerables, I'm going to cheat a little bit and use the empty function, but otherwise it's the same concept. So without writing any other code, except for we've got map via reduce, has the exact same type signatures, all that same stuff, I know what my return statement has to be. It has to be this thing. The whole source.reduce, given an empty enumerable, and this reducer function. But now the problem is, what the heck does this reducer function look like? Well, with the magic of PowerPoint editing and some IntelliSense here, here's what's got to look like. The reducer function has to be something that says, given an IEnumerable of t results and some t, I got to give you back an IEnumerable of t result. I got to figure it out. What we need to do is we need to figure out some way to convert an item that's a t to t result. And once we figure out how to make that conversion, we've got to append that converted item to the list of values. If we can figure out these two steps, man, we're golden. This is easy. So anyone want to take a guess what we could use that can maybe convert an item from a t to t result? Let's take a look. So the good news is we've got a little bit of help. We were given a func as part of the signature for map that allows us to do that, right? So now that we have selector, we can just straight up use that. Cool. Here's a function, tells us go from t to t result. So step one, mission accomplished. Step two, though, we got to append it somehow. Well, how do we do that? Well, I'm going to cheat a little bit. I'm going to use the append method that sits on IEnumerable to add this. For those playing along at home, you can write your own version of append. It's not too terribly bad. It's just a little bit outside the scope of what I was wanting to talk about tonight. But that's essentially it. You convert the item to a converted item with using the selector function or selector func that we were passed in, and then we just append it to the list of values. It works. Still lazy, follows all the same properties. Is this a little bit hard to read? Oh, absolutely. Once again, please don't write this as real production code. But did we do the refactor? Yeah. And honestly, it may not have been too terribly bad. We just had to realize that the big thing that we needed was handed to us as part of the type signature at the very beginning. So that was kind of cool. All right, let's take a look at doing keep as the same way. Right, so here's what our original implementation is. So remember, we got to figure out our initial value, and we got to figure out what a reducer function is going to look like. So for the initial value, same question. What happens if source is empty? What happens when you call where on an empty list? What do you get back? It's an empty list, right? So we can use the same enumerable tsource.empty. We can use that same function. So we plop that in like we did last time, right? Source.reduce, enumerable.empty of t. Here's a reducer. And the minute we say, hey, what does this reducer func got to look like? It's got to look like the following, right? We have some function that says, hey, given an IEnumerable of t and then an item of t, we got to return back an IEnumerable of t. So there's two steps here. We got to check to see if the item meets the criteria, right? Should we keep this item? And if so, we need to append it to values. Two steps. If we can write this out, we've got a reducer function knocked out. So what could we use to let us know if an item fits our predicate, like it matches the criteria?
Selector.
We don't quite have a selector, but close, right? It's that predicate, right? It's that thing that got passed in as part of keep via reduce, right? So when we put that in, we can say, hey, cool, use a predicate. And so now we've got this kind of cool if else thing going on, right? If predicate item, if that's true, we got to do something. Otherwise, we got to do something else. So I think we know how to append an item, right? We just did that in the map. So we can use that logic here, right? So if it matches the predicate, we append it. And that's what we return, values appended with that item. But if it doesn't match, cool, no harm, no foul. We return back those values. Pretty nifty. So I've talked a lot this evening about some fonts, extension methods, everything. So I just want to do a brief recap, right? So we've talked about LINQ, talked about some of the cool stuff, some reasons why I think it's pretty powerful and why you should be using it. We spent a little bit of time talking about how does LINQ work, right? Talked about some fonts, some generics, some extension methods. We had some jokes. We laughed, maybe cried. We implemented our own version of map, keep, and reduce, and we even refactored those to only be reduced. And I know there's a ton of stuff here and maybe not all that made sense, but the big thing I also want to make sure you keep with is LINQ's not magic, right? It's not this voodoo that was passed down from Microsoft and it's incomprehensible. Quite the opposite. It's actually pretty common sense stuff. You could have derived it. Hell, we did that this evening in 60 minutes from someone who's not even an expert in all this stuff, right? So LINQ's not magic. It's actually just a composition of three things: funcs, generics, and extension methods. And really, what we did tonight is that we built some bigger programs by refactoring into smaller programs. And with that, that's pretty much what I had for the presentation this evening. So thanks for letting me come hang out with you all this evening. I definitely appreciate it. I mentioned it earlier, but if you want access to the slides, any of the source code, things like that, QR code on the right will help you out. If you don't mind, I'd really appreciate if you would answer the one question feedback survey with the QR code on the left. Promise it's a single mandatory question to let me know how I did, right? Things I could have improved on, things I could have done better. Otherwise, if you ever have any questions, feel free to reach out to me at the email listed below. You can find me on most social media at that handle at the bottom. Otherwise, thank you all so much for the time this evening. I appreciate it.
Any last questions from the audience, from the online audience? It's been quiet.
Oh man, I've either lost everyone 5 minutes in, or this is so just blindingly obvious.
You've blown everyone's socks off.
I've completely mischaracterized the group I was speaking to, Lee. You should have let me know that they were all like super duper .NET experts, and I should have hit them harder.
That's how Cap Area rolls.
I have a question, Cameron.
Yeah, sure. What you got?
I've been messing around with F#. If you done any F#, then what's your opinion on that?
Oh man, yeah. So I actually, poorly, I actually have a separate presentation I do that talks about how I got started in functional programming, and F# was the language I got started with. So I've never done F# professionally, but I built non-trivial projects in it for a number of years, and for the longest time it was my recommended language. It's not so much anymore, not because there's anything wrong with the language. It's just that F# is cool because it allows you to write functional stuff, but it also allows you to write OO. And so sometimes that's a good thing, but a lot of times it also convinces you to do something not so great. So if you're wanting to learn how to do functional programming, it's kind of a great tool to get started with. But if you're not careful, you'll end up finding yourself writing into a lot more OO paradigms. Also, you might find it a little bit hard to actually write F# on the day job. Some companies don't use that language, or they're not .NET shops at all. My recommended language, if you're wanting to learn to do some stuff more functional, TypeScript. JavaScript itself is a pretty functional first language, and TypeScript just makes that a little bit better. So, but otherwise, F# was definitely my gateway into functional programming. It's a solid language.
Thank you.
Yeah, you're welcome.
So Dan's interested. I'm actually curious. Does anyone else have, would anyone else be interested in seeing a Cap Area presentation on F#?
Yeah.
Absolutely.
Absolutely.
Okay. We'll make it happen. I got a question.
Yeah, sure.
How about the query comprehension syntax? That is a bit of magic from LINQ that is not easily reproduced, is it not? Or is this something you can do with the Roslyn magic of build your own compiler kind of stuff?
So to make sure I understand your question, are you talking about like the alternate form of LINQ? So instead of doing like the method chaining, you can say like from blank select. Is that your question?
Yeah, I think that's called query comprehension, but whatever.
Yeah.
Anyway, yeah, what you just.
I have no clue to actually both of them, right? I have no clue how you would actually write that. I think you would have to tie into Roslyn though, right? Like you would have to tie into some type of compiler hook to actually make that happen.
And I know nothing about Roslyn, and I would love to. So if you ever get to talk about how to make that kind of magic out of LINQ, that would be really interesting.
I can do you one better. I can recommend you a speaker for that.
Yeah.
Jason Bach. He's worked a ton with Roslyn.
He spoke here before.
Yeah, no, he's a fantastic presenter. Does quite a bit with Roslyn and like the analyzers and such. I'm not saying he would know the complete answer to your question, but if you're wanting to learn more about Roslyn, I'd definitely chat with him about it. Because not only does he do conference talks on it, but he's built like real world stuff with it.
Any other questions? Once?
So if no other questions, I'll give you all a fun little challenge to work on. We wrote, no, it's not too bad of one. So we wrote this evening, map, keep, and reduce. I hear LINQ has a ton of other operators though, like length, any, all, first or default, single or default, and some of those are overloaded. Try implementing your own versions of those. That is a fun little experiment. Ah.
That's good. Well, thank you so much for coming out, Cameron. I really appreciate it.
Yeah, you got it. Thanks y'all for letting me come hang out with y'all for the evening. It was a good time. I'm gonna stop sharing my screen right now. That way I can see your all smiling faces.
And for filling in on short notice, especially.
Oh yeah, no, absolutely. So I'll Functified. Oh man, I'm looking at the chat now. This is delightful.
I came up with a new title for your presentation, just Functified.
So I just gotta be a little bit careful because sometimes I have a small speech impediment. I gotta be real careful to enunciate some of the syllables, man. It can be a little dangerous otherwise.
Let's stop the recording.
Y'all, if there's nothing else, I'm gonna go ahead and dip out of the conversation. Thanks y'all once again.